this question I'm going to look at is from Issac Physics, Waves at Sea. It's part of the game board on refraction. So we're going to look at both parts, part A and part B. So this question here says, water waves are instant at 45 degrees on submerged rock, which slows them down. By considering the path of waves shown in figure 1, calculate the factor by which the waves are slowed down, give your answer to two significant figures. So what we're going to do is we're going to use Snell's law, and we're going to use it in the form of sine theta 1 divided by the speed of substance 1 equals sine theta 2 divided by the speed of substance 2. So we've got here the angle 45, which gives us the first one, sine 45 divided by the speed 1, and we've got our angle here of 30, which would also be this one here. So that would give us sine 30 over C2. If I rearrange those, that will give me sine 45 divided by sine of 30, which would give me my ratio of C1 over C2. And the answer it asks for is to give your answer as a factor. So that would be fine. So when I work out my answer in my calculator, it will give me an answer of 1.4. Okay, so this is part B of the Waves at Sea question from Issac Physics, game board on refraction on wave motion. So the waves now hit a wall at an angle of 30 degrees. The distance d in figure 2 equals 12 meters. A new wave peak hits the wall every 2 seconds. At what speed do the contact points between the wall and the wall peaks travel along the face of the wall? Right, so first of all we need to know about the speed of waves. So we know that the wave equation equals wave speed equals frequency times wavelength. So the frequency can be worked out by, it says a new wave hits the wall every 2 seconds, which frequency is number of waves per second, so that we know the frequency is going to be 0.5 hertz. And the wavelength can be worked out because it says D is equal to 12 meters. So we've got here one wavelength, two wavelengths, three wavelengths. So we've got three waves in 12 meters. So 12 divided by 3 would give us 4 meters for each wave. So we can work out the wave speed, which would be 0.5 times 4, which gives us a wave speed of 2 meters per second. So that is the wave speed, but you've got to think of it, it's on a triangle, so we can see, so we can start using trigonometry here. So we can see that the angle is 30 degrees, and we know that if it was coming in at this angle here, it would be 2 meters per second. So we're talking about vector addition here. So what we can do is we know our opposite, we know our angle, so we can use trigonometry, and we know that the sine of the angle equals the opposite over the hypotenuse. We want to work out the hypotenuse. So what we're going to do is we're going to do rearrange that to give us 2 over sine 30, which gives us an answer of 4, and it's a velocity, so it's 4 meters per second.